The next section we're looking at is factoring perfect square trinomials. Ayana, can you read this whole thing for us?
Factor perfect square trinomials. You have learned the patterns for the products of the binomials a plus b squared and a minus b squared. Recall that these are special products that follow specific patterns. These products are called perfect square trinomials because they are the squares of binomials. The above patterns can help you factor perfect square trinomials. For a trinomial to be factorable as a perfect square, the first and last terms must be perfect squares and the middle term must be 2 times the square roots of the first and last terms.
Okay. So, that is just a whole lot of jumbo for a very simple thing. Okay? Let's take a look here, what we have here. This is telling us that a plus b squared. First thing you have to recognize with square just means we're multiplying it twice, right? If we were to multiply this out doing the box method or distribution, it would look like this. Combine your like terms in the middle, so this is the actual form of this. It's the same thing. We're just writing it out. Same thing over here. A minus b squared, that just means a minus b times a minus b. When you multiply it out, you get that. And then you combine these two like terms in the middle. So both of these are perfect square trinomials. Let's take an example. Let's look at what they were talking about first term, first square, and all that other goodness, graciousness. I can't get it to look right. So looking at that trinomial, 16x squared plus 24x plus 9. So first you look at the first term. Is it a perfect square? Well, is 16 a perfect square? Yes. Is x squared a perfect square? Yes. So that term works. Look at this term. Is this 9 a perfect square? Yes, because 3 times 3 is 9. Now, what they were talking about for the middle term. Take the square root of 16x squared. So the square root of 16x squared is what? 4x. The square root of 9 is what? 3. All this middle term is 2 times these two. So what's 4x times 3? 12x. This number has to be twice that. Is this twice that number? Yes, because 12 times 2 is 24. So this is a perfect square trinomial. We took the square root of this times the square root of this. This middle term has to be twice that. Okay? So look at the actual concepts that we wrote down. I hate when I do that. So looking at what we wrote down. Look at this example here. Is x squared a perfect square? Yes. What's the square root of x squared? X. Is 16 a perfect square? Yes. What's the square root of 16? 4. What's 4 times x? 4. Is this middle term 2 times 4x? Yes. So is this a perfect square? Yes. Easiest thing ever. X plus 4 times x plus 4. Only because it's following the actual perfect square formula. These formulas are on your formula chart. That's why I'm showing you this. Okay, so even if we forget how to do the whole T-chart thing, these are on your formula chart, so use them. Same thing here. Is x squared a perfect square? Yes. What's the square root of x squared? X. Is 9 a perfect square? What's the square root of 9? What's 3 times x? Is this middle term 2 times that? Is it? What's the difference between 6x and what we have in the middle? What we have in the middle is negative, right? Be careful. That's different. Okay? But here, there's a formula for that one. Even though it's negative, it's still negative 2ab, correct? So that's why we use this second formula. X minus 3 times x minus 3. Okay? And once again, like I said, there's a way you can check your answer. All you would have to do is do box method and multiply it out. So let's do an example. Let's do an example. Let's say we have 4y squared plus 12y plus 9. Because you can see that. There you go. Okay, so the first thing we got to check is the first term. Is that a perfect square? What's the square root of 4? What's the square root of y squared? Good. Is 9 a perfect square? What's the square root of 9? Now what's 2 times? 2y times 3? Is this middle term twice that? It is, because 2 times 6y is 12y. So is this a perfect square trinomial?
Yes.
Yes. Now look, now all we have to do is go back to the actual formula. All we're going to write it as is a plus b times a plus b. So looking back here, a, b, c. So when we write that out, the square root, I wrote that wrong, a, b, c. It's going to be 2y plus 3 times 2y plus 3. That was not a, b, c. How can we check this? Box method. Good question. A is the number where?
In the top left.
The first term.
A is the first term. But notice how this is squared, right? A is not the actual squared term. A is the square root of the squared term. The entire term is squared. A is just the actual square root of that term. So here, when we wrote the square root of 2y, that's A, 2. Here, when we wrote the square root of 3, that's B. I know, it's confusing. Let's do another example. Nine y squared plus 24y plus 16. What's the first thing we check? Is this a perfect square? What's the square root of 9? Square root of y squared? Y. Is 16 a perfect